Have you ever wondered why some parts of the Earth seem to erupt with fire and fury, while others remain calm? Welcome to the Ring of Fire, a vast horseshoe-shaped region where the Earth's crust is alive and constantly reshaping our planet. In today's video, we'll dive into the science behind this fiery phenomenon, explore a recent volcanic eruption, and uncover the forces driving these dramatic events. Just last week, Mount Merapi in Indonesia erupted with tremendous force, spewing ash thousands of feet into the air and forcing hundreds of families to evacuate. This eruption disrupted air travel, destroyed nearby crops, and reminded us of the incredible power hidden beneath our feet. Indonesia, located at the heart of the Ring of Fire, experiences more volcanic activity than almost any other place on Earth. But why is this region so volatile? To understand, we need to look beneath the surface and uncover the science of plate tectonics. The Ring of Fire encircles the Pacific Ocean, stretching from South America to Asia and back to North America. It is home to 75% of the world's active volcanoes and experiences 90% of the planet's earthquakes. Its existence is due to a combination of factors that are not found together in other parts of the world. Here's why it forms here, and why such a ring doesn't exist elsewhere. The Pacific Plate is the largest tectonic plate on Earth, covering most of the Pacific Ocean. It is surrounded by multiple smaller plates, including the North and South American plates to the east, the Eurasian and Philippine plates to the west, and the Australian and Antarctic plates to the south. These numerous interactions create a variety of tectonic boundaries, subduction zones, transform faults, and divergent boundaries all around the plate. This makes the Pacific Plate a hub of intense tectonic activity, resulting in the formation of the Ring of Fire. Most of the boundaries around the Pacific Plate are convergent boundaries, where the denser oceanic plate is forced under lighter continental plates in a process called subduction. To the east, the Nazca and Cocos plates are subducting beneath the South and North American plates, forming the Andes and the Cascades. To the west, the Pacific Plate is subducting beneath the Eurasian, Philippine, and Australian plates, leading to the formation of volcanic island chains like Japan and Indonesia. Subduction zones create the conditions for intense volcanic activity and earthquakes, which are the hallmark of the Ring of Fire. In the Atlantic Ocean, for example, there are few subduction zones, so volcanic activity is less intense and limited to mid-ocean ridges. The Pacific Plate is one of the fastest moving plates, shifting at a rate of 7-10 centimeters per year. And faster plate movement leads to higher friction and greater buildup of stress at plate boundaries. This results in more frequent and powerful earthquakes, as well as heightened volcanic activity. And faster plate movement leads to higher friction and greater buildup of stress at plate boundaries. This results in more frequent and powerful earthquakes, as well as heightened volcanic activity. The Ring of Fire includes a mix of tectonic boundaries, convergent boundaries, where subduction occurs, leading to the formation of deep ocean trenches and volcanic arcs, divergent boundaries, such as those in the South Pacific, where plates are pulling apart, and transform faults, like the San Andreas Fault in California, where plates slide past each other. This combination of boundary types is not as common in other regions, making the Ring of Fire a geologically unique zone. Let's check similar structures around the world. Atlantic Ocean has mostly divergent boundaries, for example, the Mid-Atlantic Ridge, where plates are moving apart, resulting in underwater volcanic activity but no large-scale subduction zones. Indian Ocean. While there are some subduction zones, for example around Indonesia, they are more localized and don't form a continuous ring. And the Southern Ocean? The Antarctic Plate mostly interacts with divergent boundaries, leading to limited volcanic activity. Now you can understand why is the Ring of Fire unique. It's a result of the unique combination of the large size and central position of the Pacific Plate, the presence of multiple subduction zones surrounding it, the high-speed movement of the Pacific Plate, and the diverse and dynamic tectonic boundaries around its edges. This set of conditions doesn't occur anywhere else on Earth, making the Ring of Fire a one-of-a-kind geological feature. Back to our subject along the Ring of Fire, the Pacific Plate is being forced beneath other plates in a process called subduction. As one plate dives beneath another, it melts, forming magma that rises to the surface, fueling volcanic eruptions like the one we just saw. In subduction zones, the intense heat and pressure melt the descending plate, creating magma chambers. When the pressure becomes too great, the magma escapes through weaknesses in the crust, causing an eruption. This is why regions like Indonesia, Japan, and the Philippines experience such frequent volcanic activity. The Earth is constantly reshaping itself in these zones of immense pressure and heat. Volcanic eruptions have immediate and long-term impacts. Locally, they can destroy homes, farmland, and ecosystems. But their effects can also reach far beyond the eruption site. Large eruptions release massive amounts of gases like sulfur dioxide into the atmosphere, which can temporarily cool global temperatures by reflecting sunlight away from Earth. While these cooling effects might seem beneficial in the age of climate change, they come at a cost. Ash clouds can disrupt air travel, harm respiratory health, and even impact weather patterns. So what does the future hold for the Ring of Fire? Scientists are working tirelessly to monitor these volatile regions, using advanced technology to predict eruptions and warn local populations. However, the forces driving these phenomena are ancient and unstoppable. While these eruptions can be devastating, they also create new land, enrich soils, and remind us of the Earth's incredible ability to transform and adapt over time. The Ring of Fire is a testament to the raw power of our planet, a place where destruction and creation happen side by side. What do you think? Are volcanoes a threat we need to fear, or are they a reminder of the beauty and resilience of our Earth? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into Earth's mysteries.